Good afternoon, class. We are looking at module 1, which covers chapters 1 to 3. Here's chapter 2, exploring data with tables and graphs. So given the frequency table, answer the following questions, starting with the number of classes in this table. So as you can see, we have 1, 2, 3, 4, 5 classes. 5 is the number of statistical age groups defined here. Therefore, the number of classes is 5. Part B, we are interested in finding the class width. Let's look at the definition of a class width. And before even we do that, I want to make sure we understand. We are looking at limits here. These are the lower limits. These are the upper limits. And the frequency of the age group between 11 to 20, for example, is 5. The next group is 6, so on and so forth. So lower limits, upper limits. The class width is 10. Why is that? Upper limit minus lower limit plus 1 unit. Now, I want to explain this unit. This unit may be 1, maybe 10,000, maybe 0.1, depending upon what type of numbers are given. Or difference of 2 consecutive lower limits or upper limits, for example, 21 minus 11. So you can look at these two. You can look at these two. As long as they are consecutive, you can come up with the width. I want to erase that. The midpoint of the 4th class. So again, this is 1, 2, 3. Here's the 4th class. The midpoint, you add up the lower limit and the upper limit, you divide by 2. In this case, we have 41 plus 50 divided by 2, which results in 45.5. So what is the definition of a midpoint? Lower limit plus upper limit divided by 2. That would be the definition of the midpoint. What is the lower boundary of the 5th class? First of all, this is the 5th class. To find the boundaries, if we add up these two, that means the upper limit of the 4th class, the lower limit of the 5th class, add them up, divide by 2, it becomes the upper boundary of the 4th and lower boundary of the 5th class. So it is the midpoint of the upper limit of the 4th class and the lower limit of the 5th class. Add these two numbers, divide by 2. What is the upper limit of the 1st class? So here's the lower limits, here's the upper limit, and we want the upper, these are the upper limits. We want the upper limit of the 1st class. For this class, the upper limit is 20. What is the sample size? You look at the frequency of each class and add them up. That becomes n, or summation of x, which is the sample size. We are adding this last column. The sample size is. The relative frequency of the first class. The relative frequency of any class is defined as the frequency of that class divided by a total size. So the denominator is this total size we found, and the relative frequency for the first class therefore becomes 5, which is the frequency of that class over the total size. So RF, relative frequency, is defined as the frequency over n. In this case, the relative frequency, you can represent it with a fraction, decimal, or percentage. All right. What I want to look at, I want to show you that this is really done in a table. In other words, when we have this frequency distribution table, FDT, the midpoints, you put them in a table in a column next to them. For example, this one is 11 plus 20 divided by 2. This one is 21 plus 30 divided by 2, so on and so forth. Now, what is interesting, if you calculate one of them properly, 15.5, and then you remember the width was 10, if you add the width, you can get the next one, 25.5. You add the width, the next one, the next one, and the next one. So knowing the width is going to really help out with the calculation, and it's going to go pretty fast. As far as the boundaries are concerned, as long as you calculate one of them, for example, if you add these two, 20 plus 21, and divide by 2, you get 20.5. It gives you these two. The rest of them, we said the width is 10. So add 10. And for the lower boundary of the first class, subtract 10. So all you have to do, calculate one boundary and then use the width and quickly come up with the rest of them. How do you come? This is LB, lower boundary. This is UB, upper boundary. RF, relative frequency, is defined as F over N. So this one would be 5 over 35. This would be 6 over 35, 9 over 35, and always put them in lowest term. Relative frequency, you may use a percentage to represent that, or decimal, or fraction. And again, the boundaries definition was given. We want to find the model class. So it refers to the class with the highest frequency of occurrence. So you look at this column and look for the largest number. The largest number is 11. So this is the class of interest. The model class is class number 4, the fourth class, which is going from 41 to 50. The largest frequency is 11. Therefore, the terminology is model class. Now, what is the mode? We take the midpoint of that class to represent the mode. The midpoint represents the mode. The following frequency table describes the speed of drivers ticketed through a 30 mile per hour speed zone. Calculate the relative frequencies for all classes. So this is given. Frequency distribution table. For example, the speed of 42 to 45, there were 25 drivers, so on and so forth. So we want to find in part A relative frequency. RF is defined as F over N. So first we need to calculate the N because we need for all of them. That means we are going to add 25, 14, 7, 3, 1. Add those numbers. And that is 50. So first add the numbers 25 plus 14 plus 7 plus 3 plus 1. Add them up. And so F over N, for example, this one is 25 over 50, which becomes 1/2. This one becomes 14 over 50, which is 7 over 25. You can figure out the rest. So again, divide every number in this column by 50. And as always, anytime we are dealing with a fraction, we put it in its lowest term. Part B, what percentage represents the speed of 53 miles per hour or less? So you look for the upper limit of 53, and as you go through that, this is the upper limit. So you have a choice adding these numbers and divide by 50, or add up the relative frequencies. This is a little bit more precise in case you go with decimal representation and you truncate it at some point. So basically 25 plus 14 plus 7 divided by n, the total size of 50, gives you 46 over 50, which is 92%. Or you can add these three numbers. 0.5, 0.28, 0.14, either way is fine. So 92% represents the speed of 53 miles per hour or less. We are looking for the boundaries. So again, if you add these two, divide by 2, you get 45.5. The class width will help here. The class width is 4. We call boundaries are the midpoint between the upper limit of one class and the lower limit of the next one. And so this is 45.5. This is 45.5. Because again, I want to make sure 45 plus 46 divided by 2 gives us 45.5. Now we can calculate the rest of the boundaries, or we can go with the easy way out. The class width is 4. The reason why, for example, you can say 58 minus 54. Or if you go this route, the upper limit is 53 minus the lower limit is 50 plus 1 unit. However you look at it, the answer is 4. Therefore, we just keep on adding 4. So we add 4 here, for example, becomes 49.5. And we put it right here too. 49.5. And then add, we get 53.5. What about the lower boundary of the first class? Subtract this 4 from this, and it gives you 41.5. So let me make sure everybody can see what happened here. So this number is 45.5 minus 4. That would be the fastest way to calculate this. All right, we are looking at the same thing. Let's see what we want to do here. So that's the same question, part D. Construct a histogram corresponding to the frequency distribution table. When you construct anything, just pay attention to what they ask us, frequency distribution table or percent frequency, so on and so forth. You want to be very careful. So basically, what you have here, you are going to draw a vertical axis, a horizontal axis. Along the horizontal axis, you have the speed in miles per hour. And as far as the horizontal axis is concerned, what you can put in, you can put in the limits, you can put in the midpoints, you can put in the boundaries. In many texts, they use boundaries because later on when we look at ogive, we have no choice but to use the boundaries. So many do that. However, it may be the limits, and that's fine. Again, limits, boundaries, midpoint. So you have that. And then what is your vertical axis? Depending on what the question is asking. If it's frequency distribution, so you put the frequency. If it's percent frequency, you put the percent. So the vertical axis for the first group, 42 to 45, is 25. The next one is 14, so on and so forth. So I hope you see that we can use either the limits or the boundaries. I'm going to go back to that discussion in a moment. But this is the very first one, that first class 41.5 to 45.5, with the height being the frequency of 25. Then next to it, a bar with the same width, because the width is the same, 49 points. This is 45.5 to 49.5. And the height equals 14. The next one, the height is 7. The next one is 3, and the next one is 1. As far as what goes here, you may use, so you can also use limits. You could say 42 to 45 and 46 to 49 and so on and so forth. You could also use midpoints. Now, if you use limits, now the way it is right now, if you notice, if you subtract those boundaries, that gives you the width, okay? That gives you the width. So for example, 45.5 minus 41.5, we already know the width was 4. Let me just write that. So we know the width is 4. So any of them that you use, 61.5 minus 57.5. If we use the limits, because the limit, there is a gap, 42 to 45 and then 46 to 49. If they use that in some text, including my OpenMath, they just use upper limit minus lower limit. Instead of here that you calculate upper limit minus lower limit plus 1 unit. Remember what I told you in order to calculate that. So in that case, if you're using it right here, just upper limit minus lower limit will do the job, just like the boundaries. All right, the following frequency table describes the speed of drivers. We are looking at the same thing through a 30 miles per hour, 30 mile per hour speed zone. We want to come up with the cumulative frequency distribution and cumulative relative frequency. The most important thing is to understand this one and what it means. As long as we have that, we are in good shape. So what is given is the basic frequency distribution table that everybody is familiar with. So what we do, we want to go from this one to a cumulative frequency. As the name indicates, cumulative is cumulative, we add up from the beginning. So the most important thing is to understand what happens to this piece that represents the classes. This one will change in the following manner. The lower limit of each class remains as the lower limit of the first class. That is the concept of cumulative. So all of these numbers will change to 42. If we do that, and this is not the only way, it makes it easy to understand the concept of a cumulative frequency. I'll explain other methods that you may come across. So first and foremost, keep intact the upper limits, don't change them. And the lower limit of the first class is 42. Apply that to each and every class. That is the meaning of cumulative frequency. That is the meaning of it. Now, let's go back to the second column. Obviously, the first one is still 25, and it makes no difference. But now from 42 to 49, that means from here to here. So you need to add these two numbers, 25 plus 14, and you write in front of it 39. Now 42 to 53, that means all those three. So whatever you had here, which was 39, you're going to add to 7, and in front of that, you're going to put 46. 42 to 57, that means all the way to here, all those. So you add another 3, you get 49. And 42 to 61, the last one, you always get n or 50. So pay attention to this. The cumulative frequency, basically, you add them up accordingly. The first one doesn't change, then you add these two, then you add all 3, add the 4, and add all 5 for the last. Now, in some text, they just use the boundary, which is 45.5 here, and they, instead of this, they write down less than the boundary, which is 45.5. So this statement goes here instead of that. And that's absolutely fine, but I like to start with the lower limit of the first class for each and every one of them, because I think when we do that, it makes it easy to understand and remember the meaning of this. So less than 45.5. In fact, some even use less than, and they put the lower limit of the next class, so less than 46. I believe this is the best format, but either way is fine. Now, the next one is asking for the cumulative relative frequency. It's obvious that the same thing happens here. We are going to divide this column, each and every one of them, by 50. So 25 by 50, 39 by 50, and so on and so forth. So if you have the previous page done, you can simply add up. You remember the relative frequency that we had for those, you can add them up. Either way is fine, but this is pretty exact. 25 divided by 50, 39 divided by 50, so on and so forth. What is important is this: the last one must always be 1 or 100%. It's a relative frequency, okay? So cumulative relative frequency, the last one must always be 1 or 100%. and the cumulative frequency must always be n. This must always be n. This must always be 1 or 100%. Otherwise, we've made a mistake. So we are looking at the same thing. Could somebody read this question, please?
Continued. The following frequency table describes the speed of drivers ticketed through 30-mile-per-hour speed zone. Draw an ogive of the cumulative percentage distribution. Using the ogive, find the percentage of drivers who drove 47 miles per hour or less.
Excellent. Thank you so much. So we do have the information from the previous, part. We have done this. We've come up with the cumulative frequency and cumulative relative frequency. What really is important is to pay attention to this. Are they asking for an ogive for percentage, or they're asking for the frequency? Because they are asking for the percentage, we are going to use this column. So what happens is that along the x-axis, we will have the boundaries. The lowest boundary is 41.5, the highest is 61.5, and we go from 41.5 to 45.5 to 49.5, all the way to the last one. And in front, the lowest boundary, that means the lower boundary of the first class corresponds to 0. This corresponds to 0. The highest boundary, that means the upper boundary of the last class, corresponds to 1 or 100%. In between, now this one corresponds to 50%, this one corresponds to 78%, so on and so forth. And it will look like this. I want to make sure everybody understands what's happening, so I'm going to go over that one more time. The lower boundary of the first class always corresponds to 0. The upper boundary of the last class will always correspond to 1 or 100% when it comes to percent frequency. If it said frequency, then, okay. If it said frequency, then this will correspond to n, the total size. Then what we do, for the 5.5 corresponds to 50%, 49%, 49.5 corresponds to 78%, 53.5 corresponds to 92%, 57.5% corresponds to 98%. And when we connect them with line segments. These are not curve, line segments. That's how we do with ogive. That's part C. Again, the thing you want to be careful. This will be always the boundaries. The height could be the frequencies, or percent frequencies, which one we have to read and act accordingly. Now, the next one says, using the OJI, find the percentage of drivers who drove 47 miles per hour. So locate 47 along the horizontal axis. Go straight up and to the left, and that's the number that you're looking for. So number 47 is somewhere between 45.5 and 49.5 on the horizontal axis, which corresponds to approximately 60%. Therefore, 60% to 61% of drivers drove 47 miles per hour or less. That's how ogive is used. All right. We have the following sample. The ages of 40 tenured faculty at CSULB, and it's 40. And we want to construct a dot plot and a stem plot. So let's do that. First, the definition. Could somebody read that, please?
Definition. A dot plot is a graphical display of data using dots for relatively small data sets where values fall into a number of discrete values categories. Data values are plotted as dots along the horizontal scale of values. Equal values will be drawn as a stack of dots.
Perfect. So that's the definition of a dot plot. How do we do that? Let's start with sorting out. And I had put this as the smallest number, the largest number. So you have to put them in order from smallest to largest. That makes it much easier. Then we are going to have a number line such that those numbers can be clearly put on. For example, if you look at this one, we figure the way the numbers are given, maybe we want to go with 30, 35, 40, 45, 50. So we are separating them by 5. And of course, we have 1, 2, 3, 4, 5 in between. So you have some sort of a number line. And now you are going to stack up the numbers. How? So locate number 32. So roughly this is 35. This is 31, 30, 31, 32. So roughly here, you put a dot here. Then you go to 37. So between 35 and 40 is 37.5. So somewhere here you put a dot. 39, close to 40, you put a dot at top. 42, 43, 45, for example, right here you put a dot, 46. But I want to explain what happens to 47, for example. So you find 47 and you put 2 dots, one here, one at top of it, just as an example. 48, 49, 50, 51, 52, you put 2 dots for 51. You get to 53. Somewhere here you find 53 and you put 1, 2, 3 dots. You stack them up. That's how you do the dot plot. So it will look like this. Those dots correspond to those numbers and they are stacked up, as you can see here. All right. So for example, 59, 1, 2, 3, 1, 2, 3, 58, 1, 2, 3, we see 1, 2, 3. And clearly the ages range from 32 to 63. So that's a good piece of information. Also, there is more tenured faculty at older. See, these numbers are higher, right? At older ages. We're going to look at the same question, but this time we want to come up with stem plot, also known as stem and leaf plot. And it's the same question, and we need the sorted one from smallest one to largest one. So how do we do that? First, let's look at the definition. Could somebody read this definition for us, please?
I can, Professor, if you want me to.
Sure, please.
Okay. Stem plots, stem and leaf plot display the data in order from smallest to largest. A stem plot, like a histogram, is a tool to help you visualize a quantitative data set. The name stem plot is because there is one stem with the largest place value, digits to the left, and one leaf to the right. We can see the distribution of data while keeping the original data values.
Excellent. So how do we do that? When we look at these numbers, you see that we have 32 to 39. That means we have 3 and then 279. Then we have 40 all the way to 49, 50, so on and so forth. So we're going to put the tens digits. That means 3, 4, 5, and 6 in this column. Okay, that's the stem. And now we're going to go with the leaf. So we start with 32, 37, 39. So next to 3, we're going to put 2, 7, and 9. Then when we go to 4, we put 0, 2, 3, 5, 6, 7. There are 2 of them, so we have to write 7 and 7. And then 8, 9. So take a look. It is extremely important to repeat what you have. So I want to show you. There are 2 of that. You must write both of them. We do the same thing with 5. We write all those numbers and take a look at what happens with 5. We have 0 and then 1, 1. So if we were to read that if this is 50, this means 51, this means 51, this means 52, so on and so forth. When you get to 53, 1, 2, 3 of them, there are 3 of them. That's why you put 3 times. You finish that, you go to number 6, and you do exactly the same. And notice we have 60, 60, so we have 0, 0. 61, 61, this same thing, 1, 1, and then 2, and then there are 2 people who are 63 years old, 3 and 3. And again, we are getting to the same result, namely the ages range from 32 to 63 years. Also, there is more tenured faculty at older age.